Alright, so today we got a real quick lesson on systems of linear inequalities. And so last unit we graphed linear inequalities, and that was where we, graphed a line, and then we did some shading. And maybe we shaded above it, maybe we shaded below it, maybe the line was dotted. We had all sorts of things to consider. So we're going to start by just, reviewing that, and we're going to graph the inequality y is less than 2x minus 5. Okay, well, if, maybe I'll say that this is negative 5, and a line with slope 2 is that's pretty steep. So here I am drawing it with slope 2, except it needed to be a dotted line because it's strictly less than. And so I'm going to go through and I'm going to erase a little bit so that it looks like a dashed line. All right, there we go. Okay, and since we said y is less than 2x minus 5, we're interested in the areas where y is less. And so down here, y is less. So that's where I'm going to shade this whole region. And now, if we have two linear inequalities, we have a system of linear inequalities. That's going to be two different shaded regions, and the solution set will be the set of all points that satisfy both inequalities, which will turn out to be the overlap of the two shaded regions. Okay, so I'm going to start by graphing the same one. Maybe I'll say this is negative 5. And that's probably not steep enough. Probably need to have it be a little steeper than, like that. That looks pretty good. And then y is greater than negative x plus 2. Okay, well, maybe this is 2, and negative x, slope negative 1, so right, now the first one is where y is less. Okay, so I'm going to shade down here where y is less. And it's everything below this one. The second one is where y is greater. Okay, so I'm interested in where y is greater than the line that slopes downward. Okay, so it's going to be all of this area. So like that, put it all together, the solution to this system of linear inequalities is this region where I have yellow and green highlighters. So maybe I'll just kind of shade that overhead. Okay, next we've got a different system, and this one, you could attack it one of two ways. You could, if you prefer to just solve for y and get it in slope-intercept form, that's perfectly valid. What I'm going to do, though, if they give it to us in standard form, I'm going to find the intercepts, I'm going to plot them, and I'm going to connect the dots. So for this first one, I'm thinking x-intercept, that's where y equals 0, negative 2x is 5, x is 5 over negative 2, or 2.5. Okay, then the y-intercept will be where x is 0, and so that will be y equals 5. Okay, the bottom one, x-intercept, 3x equals negative 4, x is negative 4 divided by 3, and the y-intercept, that's where x equals 0, 2y is 4, negative 4, y is negative 2. Okay, so I will start by, I guess, just like graphing this one in red and graph this one in blue. So the one in blue, x is negative 4/3, it's a little more negative than negative 1, and y is negative 2. Okay, that's greater than or equal to, so it's going to be a solid line. And for the first inequality, I've got x is negative 2.5, so that's, quite a ways more negative than this. Okay. And y is 5, which is all the way up here. And it's a strict inequality, so I'm going to, just keep the dashed line. Okay. And the first one, the red one, y is greater, so that's going to be up here. everything above this line. And it's also greater for the blue one. So I'm going above that one. Okay, so we want the overlap, and that's going to be this upper region here, where it's above both lines. Okay, so it's so probably want to extend this blue line a little bit, and it's that upper region. Okay, and then maybe we'll take a system with more than two inequalities. So first thing I'm saying, x is greater than or equal to 0. Well, okay, that's basically everything to the right of the y-axis, because the y-axis is the line y equals 0. And so I'm going to just, kind of ignore the left half of the plane. And there it's gone. And then, well, where y is greater than or equal to 0, that's now just going to be the first quadrant if I want x and y to both be positive. So I'm just going to get rid of that area too. And now I just need to graph these two lines. Okay, so x plus y is less than or equal to 5. That's basically the same as y is less than or equal to negative x plus 5. So maybe I will let this be 5. And I'll have a slope of negative 1, which means it's going to intercept over here at positive 5. And it's less than or equal to, so it's, a solid line. And we're interested in where y is less than or equal to that. Okay, on this one,
We can't use a graphic calculator.
no, you are not allowed a graphing calculator in this course. And then the next one is y is less than or equal to negative 2x plus 7. So, maybe this is 7. And if it has a slope of negative 2, that's going to intercept here at 3.5. Okay. And if it's less than, we're looking for where we're below both of the lines. Okay, so where we're below both of the lines is going to be, here I'm below both of them. And up here too, but I got to stop there because I got to be below both of the lines. Okay. And not something that we're super concerned with here, but if we wanted to find this corner point, which is something you do in a lot of algebra courses if you, are trying to maximize or minimize some sort of, quantity under some kind of constraints, was we could find this point by doing substitution or elimination on this system. We could say, if I wanted to find the x-coordinate, I could set the y's equal to each other and say negative x plus 5 equals negative 2x plus 7. Add 2x to both sides. Subtract 5 from both sides. X would equal 2. And then, y would satisfy both of those equations. So, you could say y is equal to negative 2 times 2 is negative 4 plus 7 is 3. Or you could use the other one and say y is negative 2 plus 5, which is also 3. All right, the last one I'm going to graph is going to be x plus y is less than or equal to 12, which is, the type of thing that has intercepts at 12 and 12. And it's going to be solid because it's less than or equal to. X is greater than or equal to 5, so I'm going to, label 5. And we're interested in where it's greater than or equal to, so that's all of these points to the right of that line. And then y is greater than or equal to 3. Okay, well, here's the line y equals 3. And so we want to be below the slanted line, above the horizontal line, and to the right of the vertical line, which is pretty much leaving us with this little triangular region. And then the last thing we're going to do today is look at a picture of one of these regions and write a system of inequalities to describe the region. Okay, so I'm going to start with kind of the easy ones. I see that horizontal line. Okay, I've got the point 0.25 here and the point 0.75 there. That solid line is the line y equals 5. And all of the points in the shaded region are beneath that. So that means that y is less than or maybe equal to 5. Okay, over here we've got a vertical line which is going through 2, 5, and 2, 1. This vertical line is the set of all points where x is equal to 2. And then, we've got points over here where x is greater than 2, so I'm thinking x is greater than or equal to 2. Okay, the next thing, this one, yeah, I've got an intercept here, it's 3, and the slope is -1. So I'm going to say y is something like negative x plus 3. And if I look down here at this line, all the points are above it in the solution region, so it's going to be greater than or equal to. Greater than or equal to because it's a solid line. And then the last one, it's going to be the line that goes through the points 4, -1, and 7, 5. So I need to calculate a slope. So 5 minus -1 over 7 minus 4. Yeah, y'all have a good one. Is equal to 6 over 3 is 2. And then if I wanted to solve for the intercept, I could say y equals 2x plus b and use one of the points like 7, 5. Okay, so 5 is equal to 2 times 7 plus b, meaning 5 equals 14 plus b. So I think the intercept would need to be -9. Okay, so y is going to be something to 2x minus 9. And since, again, we're above this line, it's where y is greater than, we're going to do greater than or equal to.